So this video we're going to go through vectors, and this is section 3.13 on cognitive, which has some more difficult topics when we get into vectors. So the first thing is called the scalar product or the dot product. And dot meaning like, because this symbol looks like a dot. So it's really when we're multiplying two vectors and you get this formula. It's pretty easy. I like to write these out as column vectors. So 1, 4, and 6, 4. And so if I find A dot B, and the reason I'm not saying times is because there is another kind of multiplication we'll do later. So it's helpful to say A dot B. So A dot B, we just follow this formula, A1 times B1, so that's 1 times 6, plus A2 times B2, so 4 times 4. And the answer is a number, and we'll talk about what this number means. So it's a scalar number, it's not a vector, it's not like a 1 by 1 vector. It only has magnitude and not any direction. So this number, let me get rid of some of this. This number tells us, whoops, that's the highlighter. This number, notice there's our vectors A and B. That's the I plus 4j and the 6i plus 4j. And they create an angle in between. So that theta symbol represents the angle. And if we connect this and make a triangle, right here, side C would be the vector 5, 0. So now if we find the magnitude of A, B, and C, that means we're finding the length of A, B, and C. This is what we would get. The magnitude of A is square root of 17 because we're just doing 1 squared plus 4 squared and square root of that. And then magnitude of B is 6 squared plus 4 squared, square root of that. Magnitude of C is just 5 squared. Square root of 5 squared is 5. So we can use, now that we know all three sides of the triangle, we can use the law of cosines to get the angle. So yeah, that's the formula. It looks like this, cosine of, let's say, cosine of, call it theta. So the side opposite of that is C, so that's the one I'm going to subtract and do the other side squared. But if I do square root of 17 squared, I just get 17. If I do square root of 52 squared, I just get 52. But then I do have to square 5. And then all over 2 times square root of 17 times square root of 52. Because that's 2 times AB. That's what the formula says. And then we take cosine inverse, and you guys know how to do that. So we get that angle, 42.27 or 42.3 degrees. Now, let's check. This is where vectors come in. We're going to get another formula. Let's check magnitude of A times magnitude of B times cosine of 42.3. Let's check that. So that would be square root of 17 times square root of 52 times cosine of 42.3. So you can check that on your calculator if you want. The square root of 17 times, I'm going to do that on my calculator right here. Make sure we're in degree mode because it is 42.3 degrees. And I got 21.99. Does that number look familiar? It's really close to this 22 we got before. So what that means is this. Cosine of theta, cosine of this angle in between two vectors, A and B, will be equal to the dot product over the magnitude of each one. So this is a formula you get in your booklet. Right there. So example of how to use this. You'll be given two vectors. Where's my formula? And we need to find the angle in between them. So this is what we got to do. A dot B, so 3 times 5 plus 4 times 12. 4 times 12 is 48. So I add that up, 63. Okay, and that goes up here. That's what I just did. And then the magnitude of each one. So we know how to do that. This one's just going to be 5, and then the second one's going to be 5 squared plus 12 squared, and I picked these on purpose because those are Pythagorean triples. They come out to be whole numbers. So we get cosine of theta equals 63 over 5 times 13. And so this is a shortcut so that we don't have to use law of cosines, because nobody likes the law of cosines. This is a faster method. So then I do cosine inverse of 0.969, and I get about 14.25 degrees, and we could round 3 sig figs, 14.3. So that's how you use that formula when you're given two vectors, and it works in 3 dimensions as well. The dot product in 3 dimensions, I think I have an example like that. So there you go. Maybe I don't have an example like that, but I'll definitely give you a problem like that. Perpendicular vectors. So what if we have two vectors that make a right angle perpendicular? So that would mean theta is 90 degrees. Well, what's cosine of 90 degrees? If you do that on your calculator, you find that it's equal to 0. And you don't have to memorize that. You can just use your calculator. But what that means is that this whole denominator goes away. It can't be 0. Denominator, you can't divide by 0. So if the dot product is 0, then that's how you know if A and B make a right angle. So here we go. 3-dimensional vectors. We're told that they are perpendicular, so we can find x, because if they're perpendicular, this means that A dot B must equal 0 because of this result. So we do 2 times negative 10 plus x times 3 plus negative 5 and set that equal to 0. That's really easy. Plus negative 5. So then negative 20 minus 5, we're going to bump all that over to the other side. And did I do that right? Add 20, add 5, yeah. So 25 divided by 3 is some fraction. 25 divided by 3, 8.33. But I mean, really, it's exactly 8.3 repeating. Okay, so that's how you would use that formula. If you're told that they're perpendicular, you can find a missing value in your vector. So got the steps there. What about parallel vectors? So before we had perpendicular, now we've got parallel. We've got another coordinate missing here. We should be able to find it because we're told that it's parallel to this vector. So this, we don't need any fancy formula. We just look. Let's see. It says AB. So we need to find AB. Right now, this is the coordinates of A and B. But remember, the vector AB means we do B minus A. So 6 minus 1, 5 minus 3, and x minus 6. That's going to give us the vector AB. So then we do 5, 2, and x minus 6. And now I compare it to this vector. What did I multiply? Like right here, what did I multiply everything by to get the other one? And you can see from the first two values, if you multiply by negative 3, right, negative 3 times 5, negative 3 times 2, that's negative 15, that's negative 6. Those are the first two values in the vector. So that means if we multiply the bottom part by negative 3, we must get the third value. So now we can find x by distributing negative 3x plus 18 equals negative 2. Subtract 18 on both sides, and you get this. X equals 20 over 3, which is exact value. You can leave it like that if it came up, or find the decimal. So that must be our value of x. But you wouldn't have guessed that. So there we go. Last thing is area of a triangle, back to geometry. So this is the same triangle we had before. Let's just call this 42.3 for 3 significant figures. So we can find the area of this triangle because we know this formula, 1/2 AB sine theta. So we're in this situation where you know side, angle, side. So like I said, there's a lot of connections with trig. So just because we're doing vectors doesn't mean, that's all we're doing. So find the area of the triangle. It's really easy. 1/2, once you recognize A and B, and then sine of 42.3. Make sure you're in degree mode. And there we go. It's about 10. I made this before the class was supposed to be rounding to 3 sig figs. So let me just see what that would have been. Sine 42.3. Actually, this is interesting. It comes out to be 10.005. So 3 sig figs would be 10.0 because these two count and then this one would have to count. So yeah, you should say 10.0. Otherwise, you're going to get marked down on a problem like this. Okay, now go try the quizzes. Thanks for watching.